Hey there, ladies and gentlemen, boys and girls. Okay, today we're going to talk a little bit about setting up a graph and doing a proper graphing, setting it up to make sure that you eliminate as much bias and mistakes as possible. So we're going to talk about what it means to set up a good graph, and so that the graph, you can make your graph because that's where you're going to make your conclusions. That you can make a proper conclusion from that. So I'm going to kind of add on to the video that I did last time about variables and identifying the experiment. Let's say the experiment I decided to run was I want to find out the relationship between the amount of coffee I drink and how does that affect my test scores. So in this case here, my independent variable is I picked my amount of coffee, 0, which would be my control, 100 milliliters, 200 milliliters, and I got test scores of 40, 75, and 80. All right, so now we can infer some things just from that data right there, but we can get a lot more. But this is very simple data. We can get a lot more from our graph. We can make a lot more recommendations, or a lot more conclusions. And so setting it up is very, very important. Most people know how to do it, but there's always a few common mistakes that are made, and I'm going to highlight those in this video here so that you hopefully don't make those same mistakes. Okay, so the best way to check to make sure that you've made a best graph. First of all, you should always be using graph paper. The best way to check to make sure that you aren't making a mistake is to remember as a word. There's a word I like to use. It's an acronym, and that is TAILS. All right. And so remembering the phrase TAILS, each letter represents something. If you hit all the letters of TAILS in your graph, if you fulfilled all of them, then you probably have made a very accurate graph. All right. So normally I would just check through all of them here, but since I'm kind of introducing this, I'm actually going to kind of talk about them in a little bit different order, just because it helps me organically bring up some of the conversation here. So here is our data. The first thing we need to do is we have our graph paper. We have a nice setup. We have our lines and all that stuff. Is we need to set up our interval, or we need to decide which one of my variables goes here on the y-axis and which one of my variables goes here on the x-axis. All right. And a lot of people are saying, how do I know which one goes where? If you set up your variables well, this should be really easy. All right. Now you're going to have to pull in some of your math knowledge here. All right. Hate to break it to you, but science is just applied math. You learn those math skills so that you can apply them in the scientific method. All right, so we know that this is our y-axis and your x-axis. You do not have to write y and x. I'm just recapping you here. All right, we have a data table here. If you were to plot points in, say, an algebra class, in a math class, we would say that this is the x column and this is the y column. Well, in our last video, we talked about setting up a good data table, that this is actually the independent variable and this is the dependent variable. Right? And this is the x-axis, and this is the y-axis. So that means your independent variable is going to be going on your x-axis, and your dependent variable is going on your y-axis. Make sure you always include what units you're using on that. So in this case here, my independent, the amount of coffee, that's going to go on my x-axis because the independent goes in the left column. That left column is the x-axis. All right, so you should be combining some math skills here. So I should have amount of coffee. Again, I should always include my units, parentheses, milliliters. All right. That means my test scores here is going to be my y-axis. All right, that was our first part of TAILS. All right, in this case here, that was actually the letter A. All right, the letter A represents for axis labeled. All right, so once we have our axis labeled, we're ready to start putting in some of our numbers. All right. The next part here is going to actually be the S in our TAILS, and that is the scale that you will put your number on. By scale, I mean, okay, let's think about what numbers I have. I have on the amount of coffee, I have from 0 to 200. All right, which means on this right here, it should be going from 0. It should include all of 200. But at the same time, I don't want to do this as 100 here and 200 here. That's going to scrunch my graph, and it's not going to be very useful in making good conclusions, all right, from my data. I want to kind of stretch it out and have a good scale, all right? My recommendation is to try it out a little bit. Honestly, there's a mathematical way to do this, but when we're keeping numbers kind of simple, there's not, just try kind of work it out a little bit here. Let's say if I try by tens, okay, or by 50s, 50, 100, 150, 200. That's still not enough for the graph. Okay, we tried by hundreds, we tried by 50s, let's try by 25s. 25, 50, 75, 100, 125, 150, 175, 200. Hey, that's pretty much the whole graph. So I think that's the scale I'm going to use here. All right. So I'm setting up my scale here. I've included from 100. We always start from 0. All right, we always start from 0. So I'm going on the other side here on my dependent variable, my y-axis. Again, even though 0 is not a data point, I always have to start my scale at 0. All right. Next thing I have to do is my scale should go at least up to 80. Ideally, you want to go a little bit beyond that. So I'm going to make this kind of easy. I'm going to go to 100. I don't want to do it to 70 because obviously then I have data off of it. I also don't want to do it to 200 because that means all of my data would be down here then. You want to stretch out your data and your graph as much as possible. So let's say we do 100 here. Let's see, going kind of again by tens, 10, 20, 30, 40, 50, 60, 70. Yeah, that could work. 80. Okay, let's do that. We'll do it by tens. So we have 10, 20, 30, 40, 60, 80. All right. If you can go a little bit beyond it or above it. Let's say it would have been 81. I wouldn't want to do 80 here. I'd want to have to do beyond that. Okay, that's pretty good. All right. So we have our scale here. All right. This next one actually, the next letter I want to talk to kind of goes along with that as well. That's the letter I. All right. And that is your intervals. Notice here that each one of these is marked as tens, or in the case every other one is 20. All right. One of the big mistakes that I will see students make is they will change their scale. They don't mean to. They say, okay, well, I want to go up. They'll go like, okay, I wanted to start as 5, and then, actually I want to do 20, or I want to go up by 10, so I went up to make a 20. That is not an equal interval. This right here should equal this. This gap is 5. This gap is 15. This one's 10. That one's 10. So just because you have it all, it's got to be equal all the way through. All right, so make sure you have equal intervals. Your intervals are equal on both sides. You're 50, 50, 50, 50. Okay, the next one we want to make sure we want to do is eventually, we plot our data. Let's say we plot our data. And so let's see here. We got 0, 0, and 40. That's our first data point. And then we have at 175. You guys should have graph paper. That would make this a lot easier. And then at 200, I have 80. Okay, there we go. L stands for line. All right. In science, we look for trends in the data. All right. Sometimes we connect the lines. Most of the time, we do something called a best fit line. And that is a line that kind of a smooth line that fits most of the data. All right. So a lot of people are very familiar with, I'm going to use a meter stick to make sure I got my straight lines here. First of all, always straight lines. right? A lot of people would set it up like this and have nice straight lines that connects our data, all right? That's fine, but most times we're trying to see a trend, all right? And it looks like it's not a perfectly straight line here, all right? So what we actually are going to be doing is what we call a best fit line, all right? Best fit line, a lot of people think that has to be a straight line. It does not, all right? It is a smooth line, not jagged. Notice how it's kind of jagged here? In this case here, a nice straight line might work, or it could be curved. And it just depends on the data, all right? When you take Algebra 2, you learn fancy ways to do that, all right? So maybe it's a best fit line looks like this. It's kind of curved, all right? Here in physical science, we're going to try and, I'm going to try and lead you guys on this and tell you kind of how we do this. Does this look like a best fit line? I want you to try best fit line as we set this up. Either way, we need a line because we're trying to learn about something about this relationship here. Because I could expand upon it. Notice how it's kind of flattening out. Well, if I keep going with that curve, maybe, if I drink 300 cups or 300 milliliters, that's probably not going to increase my scoring much more. Right? I'm learning from the curve here in this case here. It's not a straight line. And our last one here, one that's always forgotten, is of course a title. All right. Listen, I just make this nice and easy. All right. Your title should include the variables. And a lot of people want to say this versus this. They're not fighting each other. They're not battling each other. All right. It is how we are trying to see in this relationship, how does this affect this? So that's what I would exactly do. How does this affect this? So that's exactly what your title is. All right. I would say the title for this is the amount of coffee affects test scores. Notice I included both variables here in my title. We are literally trying to find that out. The whole purpose of the question is how does the amount of coffee affect test scores? The title, if I saw this graph and I was like, I wonder what this lab was about, what this experiment was about. I should be able to tell the title right away. Oh, well, it's the amount of coffee and how it affects test scores. There's not really ambiguity there or question about what this was about. Okay, so now I have to make sure I hit all the things. I have a title. My axes are labeled with variables. I have equal intervals. I have a line, whether it's best fit, which is what we're going to try and lean towards doing. And I'm at a good scale. All my data is on my graph. My data is not crushed into this little square here. It fits the whole graph. All right, if we've hit tails, that means I've done a good graph and I can make a valid conclusion from it. All right, these are the same principles. So I always like to use tails as at the end after I make my graph. Do I fulfill all these things? Just write down the general, do I remember these things here? All right. So this is a skill that we are going to be practicing a lot this year, making sure that we can make good conclusions because it's not just about making graphs. It's about learning from those graphs. And if you make a poor graph, you're going to make a poor conclusion. All right. So if you feel like you memorize tails, that helps you make sure you set it up. Otherwise, thank you for watching and good luck. And may the science be with you. Bye.